Your optic nerve takes approximately 13 milliseconds to process an image, which means that if a gamma-ray burst struck the atmosphere above your roof at this exact moment, you would be dead before your brain ever registered the flash. There would be no cinematic moment of looking up at the sky, no realization of the end, and certainly no time to say goodbye to the loved ones sitting in the next room. You are currently sitting in a chair, perhaps holding a phone or staring at a monitor, trusting in the structural integrity of your ceiling and the magnetic field of your planet. But that safety is a hallucination born of biological ignorance. The radiation front of a burst moves at the speed of causality itself, meaning the information that you are about to die arrives at the exact same instant as the death itself. You are effectively walking through a minefield where the mines are invisible. The explosions are silent until they hit you, and the shrapnel travels at 670 million miles per hour. This is not a hypothetical scenario designed to scare children, but a statistical inevitability that has likely sterilized our galaxy thousands of times over the last few billion years. We treat the night sky as a source of wonder, projecting our myths onto constellations and making wishes on shooting stars. But this behavior is akin to a bacteria marveling at the beauty of the antibiotic that is about to boil it alive. The universe is not a passive backdrop for human history. It is a violent, churning engine of destruction where safety is a rounding error and extinction is the default state of existence. When we look up at the stars, we are looking at the barrels of loaded guns, many of which may have already fired, their bullets traversing the void for millennia, currently occupying the space just 1 light year, 1 light month, or 1 light second away from your retina. The speed of light is often discussed as a limit on travel, but its true horror lies in its function as a blindfold, preventing us from seeing the muzzle flash until the bullet has already shattered the skull of our biosphere. If a hypergiant star in the Sagittarius arm collapsed 5,000 years ago and aimed its poles at Earth, the event is already history, a done deal written in the photons rushing toward us, and we are simply living out the final microseconds of a ghost story. To understand why the universe is holding a gun to your head, you must first understand that the cosmos does not care about the complexity of your DNA or the achievements of your civilization. A gamma-ray burst is the most luminous electromagnetic event known to occur in the universe, releasing more energy in a few seconds than our sun will emit in its entire 10 billion-year lifetime. This is not merely an explosion. It is a focused, weaponized projection of pure annihilation that converts the mass of a star into a laser beam of death wide enough to engulf solar systems. When a star goes supernova, it explodes omnidirectionally, dispersing its energy in a sphere which dilutes the lethality over distance, allowing us to survive supernovae that occur relatively close by. A gamma-ray burst, however, cheats the inverse square law by channeling that cataclysmic power into two tight, narrow jets, effectively turning a grenade into a sniper rifle with a range that spans across the entire visible universe. If Earth falls within the crosshairs of that jet, it does not matter if the star is halfway across the galaxy. The intensity of the radiation hitting our upper atmosphere would be equivalent to a nuclear warhead detonating on every square inch of the sky simultaneously. The mechanism that chambers this round is a specific type of stellar death involving the collapse of a Wolf-Rayet star, a massive, rapidly spinning monster that lives fast and dies with unimaginable violence. These stars are the heavyweights of the galactic ecosystem, often 20 or 30 times the mass of our sun, burning through their nuclear fuel with a reckless inefficiency that strips away their outer layers and exposes a searing, blue-hot core. As you sit there breathing oxygen generated by plants that require a stable sun, consider that a Wolf-Rayet star is currently burning with such ferocity that its solar winds are tearing its own body apart, preparing the conditions for a collapse that defies terrestrial physics. When the fuel runs out, the hydrostatic equilibrium that keeps the star inflated against the crushing weight of its own gravity fails instantly, and the iron core collapses inward at a significant fraction of the speed of light. This is not a gentle settling of matter. It is the sudden, catastrophic failure of the structural pillars of a solar system-sized object, causing the core to implode from a diameter of thousands of miles to a point roughly the size of a city in less than a second. However, unlike a standard supernova where the star simply blows its outer layers off, the rapid rotation of the Wolf-Rayet star changes the geometry of the death, forcing the infalling matter into a swirling accretion disk around the newly formed black hole or magnetar in the center. This is the engine of the gun, a dynamo of infinite density where matter is ripped apart, superheated, and twisted by magnetic fields that are trillions of times stronger than the Earth is. The material falling into the black hole releases gravitational potential energy so vast that it overwhelms the binding energy of the star. But because of the centrifugal force of the spin, the energy cannot escape through the equator. It has nowhere to go but up and down, channeled along the axis of rotation by magnetic field lines that act as the barrel of our cosmic cannon. The star is essentially choking on its own death, and to relieve the pressure, it vomits twin jets of plasma and high-energy photons out of its poles, punching through the remaining layers of the star and erupting into the void. This entire process, from the collapse of the core to the launch of the jet, happens faster than you can read this sentence, transforming a celestial body into a lighthouse of doom that sweeps through the dark. The terror of this mechanism lies in the realization that the star's orientation is entirely random, a game of Russian roulette played on a galactic scale where the gun spins in 3 dimensions. If the star's axis is tilted even slightly away from us, we see a standard supernova or perhaps nothing at all, blissfully unaware of the bullet that just whistled past our ear. But if the axis is pointed toward Earth, even from thousands of light years away, we're staring directly down the barrel of a particle accelerator powered by the death of a god. The collimation of the beam means that the energy is not wasted on empty space, but is delivered with pinpoint accuracy to whatever unfortunate world happens to lie in its path. As you go about your day, worrying about traffic or finances, remember that there are thousands of these stars scattered throughout the Milky Way, ticking time bombs that may have already detonated, their silent screams rushing toward us through the vacuum. The universe does not need to aim to kill us. It simply needs to fire enough shots in random directions over a long enough timeline, and eventually, one of those trajectories will intersect with the orbit of our fragile, wet rock. Once the jet breaks free from the stellar envelope, the physics of the beam shifts from hydrodynamics to relativistic particle acceleration, creating a shockwave that moves at 99.999% the speed of light. This is not just light in the sense of the warm sunshine that grows your crops. This is a stream of gamma rays, the highest energy form of electromagnetic radiation, packed so densely that a single photon carries enough punch to shatter atomic nuclei. The beam is composed of shells of matter moving at slightly different speeds, and when faster shells catch up to slower ones, they collide internally, converting kinetic energy into the prompt gamma-ray emission that defines the burst. These collisions occur billions of miles away from the dying star, yet the beam remains focused, a coherency of destruction that refuses to spread out and dissipate like a normal explosion. This focus is what allows the GRB to remain lethal over distances that are incomprehensible to the human mind, bridging the gap between galaxies to snipe civilizations that have not even evolved yet. The relativistic nature of the beam introduces a horrifying temporal distortion known as superluminal motion from the perspective of the observer, compressing the duration of the event. Because the jet is moving toward us at nearly the speed of light, the photons emitted at the end of the burst are chasing the photons emitted at the start, arriving at our detectors almost simultaneously. A burst that took minutes or hours to unfold at the source might be compressed into a few seconds of intense flashing from our perspective, delivering a massive dose of radiation in a time frame too short for any biological or mechanical system to react. This time compression acts as a force multiplier for the lethality, ensuring that the ozone layer is hammered with the total energy budget of the explosion all at once, rather than over a manageable period. It is the difference between being warmed by a radiator over a year and being thrown into a furnace for a microsecond. The total energy might be comparable, but the delivery method determines survival. We must also consider the afterglow, the secondary phase of the execution where the jet slams into the interstellar medium, the gas and dust drifting between stars, creating an external shockwave that glows across the entire electromagnetic spectrum. While the initial gamma-ray flash is the bullet, the afterglow is the shrapnel and the heat of the wound, radiating X-rays, ultraviolet light, and radio waves for days or months after the event. This afterglow serves as the only warning system we might ever have, but tragically, it usually arrives after the damage is done, a forensic clue for whatever cockroaches survive the initial blast. The beam cleanses the path ahead of it, ionizing the gas and the interstellar void, effectively paving a highway for the radiation to travel unimpeded until it hits something substantial, like the atmosphere of a planet inhabited by hairless apes who think they're the center of the universe. The photons in that beam have traveled for millions of years, dodging nebulae and gravitational lenses, surviving the vast emptiness solely to deposit their energy into the nitrogen and oxygen atoms that protect your lungs from the vacuum. The narrowing of the beam implies a sinister kind of intent, even if the universe is chemically indifferent to our existence. By concentrating the energy, the universe increases the effective range of its weaponry, turning a local tragedy into a galactic sterilization event. If a GRB occurred within our own galaxy, the Milky Way, the beam would appear brighter than the sun to the naked eye, despite being thousands of light years away. It would be a second sun that appears out of nowhere, casting harsh, unnatural shadows and bathing the night side of Earth in a lethal twilight. But unlike the sun, which provides the thermal energy for life, this light is cold, hard, and sterilizing, a frequency of radiation that biology has no defense against because it tears apart the chemical bonds that hold life together. We are soft, watery bags of proteins evolved to survive under a thick blanket of air, completely unequipped to handle a direct line of sight to a collapsing star's engine room. Every second that passes where the sky remains dark is a statistical victory, a coin flip that came up heads, allowing us to continue our trivial existences for another heartbeat. But the coin cannot land on heads forever, and the galaxy is a casino that never closes, filled with high rollers like Eta Carinae and WR-104, massive stars that are currently unstable and could potentially be pointing their barrels at us right now. WR-104, in particular, is a Wolf-Rayet star located about 8,000 light-years away in the constellation Sagittarius, and distinct spiral patterns in its outflow suggest we're viewing it nearly pole-on, meaning we're staring down the throat of the gun. If WR-104 collapses tomorrow, or if it collapsed 7,999 years ago, the gamma rays are already en route, racing across the final stretch of the marathon to cross the finish line that is your DNA. There is no bunker deep enough, no shield thick enough, and no prayer loud enough to alter the trajectory of a photon that has been traveling since the dawn of human civilization. We're simply standing on the tracks, debating the train schedule, while the light of the oncoming engine is already burning our retinas. The moment the gamma-ray beam makes contact with the upper atmosphere, the physics of the event instantly degrades into the chemistry of a massacre. You might expect a massive fireball or a thunderclap that cracks the tectonic plates, but the initial interaction is far more insidious, occurring silently in the stratospheric layers that you rarely think about until they are gone. The nitrogen and oxygen atoms that make up the bulk of our air are held together by strong atomic bonds, a molecular stability that allows you to breathe without your lungs burning. But these bonds are brittle twigs compared to the energetic sledgehammer of a gamma-ray burst. As the radiation front slams into the gas, it does not merely heat the air, It shatters the molecular cohesion of the atmosphere, ripping electrons from their orbits and breaking the triple bonds of diatomic nitrogen in microseconds. This is not weather. This is the instantaneous radiological ionization of the planetary shield, converting the benign gas that insulates our world into a reactive, toxic soup of free radicals and high-energy ions. What follows is a global chemical reaction that transforms the aesthetics of the sky into a vision of hell, turning the familiar azure dome into a suffocating, bruised curtain. The liberated nitrogen atoms, desperate to stabilize, frantically bond with oxygen to form nitrogen dioxide, a heavy, brownish gas that is typically found in the exhaust fumes of diesel engines but will now saturate the stratosphere. If you were standing outside when the beam struck, assuming you were not on the hemisphere facing the blast where the immediate radiation flux would scour you clean, you would watch the blue sky curdle into a sickly, opaque orange-brown smog. This cosmic smog acts as a shroud, blocking out a significant portion of visible sunlight and plunging the world into a dim, copper-colored twilight that chills the surface. But this cooling is a deception. While the smog blocks the visible light we need to see, it actively destroys the ozone layer, the thin, fragile film of O3 molecules that serves as the only thing standing between biological life and the fusion reactor we orbit. The horror of this chemical transmutation lies in its efficiency and its longevity. The burst itself might only last for 10 seconds, but the nitrogen oxides it generates act as a catalyst that can cycle for years. A single atom of reactive nitrogen can destroy thousands of ozone molecules, eating a hole in our armor that expands until it encompasses the entire globe, leaving us naked against the cosmos. We often talk about the ozone hole as a localized problem over Antarctica, a minor concern requiring sunscreen, but a GRB-induced depletion is a global stripping event, removing up to 50% of the ozone layer in a matter of days. As you take a breath right now, consider that the only reason that breath does not taste like smog and the only reason your skin is not blistering is that a layer of gas 3 millimeters thick is holding the line. When a Wolf-Rayet star fires its round, that line evaporates, and the atmosphere ceases to be a shield and becomes a magnifying glass for the horror that follows. Once the nitrogen dioxide haze settles and the ozone is stripped away, the sun, which has been the benevolent nurturer of all life on Earth for 4 billion years, suddenly turns traitor. Without the ozone filter to absorb the high-frequency ultraviolet radiation, the sun becomes an unshielded nuclear lamp, pouring lethal amounts of UVB radiation onto the surface of the planet. This is the great dying phase, where the primary threat is no longer the distant star that exploded, but our own local star that is now free to irradiate the surface with the intensity of a sterilization lamp used in a microbiology lab. The betrayal is absolute. The very light that drives photosynthesis and warms the oceans becomes the agent of cellular destruction, breaking the DNA strands of any organism foolish enough to exist in the open. You cannot hide from the sun. It is everywhere, every day, a relentless, blinding eye that cooks the surface of the world from dawn until dusk. The collapse begins not with the burning of cities, but with the silent, invisible slaughter of the microscopic organisms that form the foundation of the global food chain. Phytoplankton, the microscopic plants drifting in the upper layers of the ocean, have no fur, no feathers, and no burrows to retreat into. They are entirely exposed to the ultraviolet deluge. As the UVB radiation penetrates the first few meters of the ocean, it shreds the chlorophyll and DNA of these organisms, causing a mass die-off that turns the oceans clear and lifeless. When the phytoplankton die, the zooplankton starve. When the zooplankton starve, the krill die. And when the krill die, the entire oceanic ecosystem, from sardines to blue whales, faces immediate famine. We are watching the bottom of the pyramid crumble, and gravity dictates that everything above it, including the 7 billion humans who rely on the ocean for oxygen and food, must inevitably fall into the ruin. There is a strong statistical probability that this is not a hypothetical scenario, but a cold case file from Earth's own geological history, specifically the Ordovician Silurian extinction event 450 million years ago. In that epoch, 60% of marine invertebrates suddenly vanished, and the geological record shows a pattern of glaciation and ozone depletion that fits the profile of a gamma-ray burst impact perfectly. We are the descendants of the few lucky species that managed to burrow into the mud or hide in the deep dark while the surface was sanitized by an invisible flash, and we carry the arrogance of survivors who believe they are immune to the cycle. But the galaxy has a long memory, and the conditions that caused that extinction are still present, waiting for the dice to roll the wrong way again. The fossil record is a graveyard of dynasties that thought they were permanent, only to be wiped out by a single bad day in the Milky Way. For the creatures living on the land, for you, the experience would be a slow, agonizing degradation of biology, a dismantling of the self at the genetic level. Stepping outside for a few minutes would result in immediate, severe erythema, blistering burns that do not heal because the radiation has damaged the skin's ability to repair itself. Crops would wither in the fields, their leaves scorched, and their reproductive cycles broken, leading to a global agricultural collapse within a single growing season. But the most terrifying effect is on the eyes. The lenses of terrestrial animals are not designed to filter such intense UV radiation, leading to widespread cataracts and blindness across the animal kingdom. Imagine a world where the predators and the prey are both stumbling blind through a dying forest, starving and irradiated, while the sun beats down on a silent, sterile landscape. We search the heavens for signals from alien civilizations, wondering why the galaxy is so quiet, why no one has said hello. Perhaps the silence is not due to a lack of life, but because every time a civilization climbs out of the mud, the universe racks the slide of a sniper rifle and puts them back in the dirt. The silence of the night sky is the most terrifying data point in the history of human knowledge, a screaming void that contradicts every mathematical model of life as probability. We look out at a universe that is 13.8 billion years old, filled with hundreds of billions of galaxies, each containing hundreds of billions of stars, and yet we see absolutely nothing looking back at us. The Drake equation and the sheer statistical weight of the cosmos suggest that the Milky Way should be teeming with noises, signals, and megastructures, a crowded metropolis of interstellar civilizations. The fact that we hear only static suggests that there is a hidden variable in the equation, a great filter that acts as a cosmic thresher, cutting down life before it can transition from simple cells to spacefaring gods. It is highly probable that gamma-ray bursts are this filter, a periodic sanitization mechanism that has kept the universe sterile for the vast majority of its history. We are not the first species to look up at the stars and wonder if we are alone. We are simply the first species to survive long enough to ask the question out loud without being vaporized by the answer. For the first few billion years of the universe's existence, the cosmos was a compact, volatile shooting gallery where safety was physically impossible. Galaxies were smaller and denser, cramming stars into tight clusters where the chain reaction of supernovae and bursts was constant and unavoidable. In that era, the rate of gamma-ray bursts was likely exponentially higher than it is today, creating an environment where any developing biosphere was subjected to a lethal sterilization event every few million years. Life, in its most basic form, is resilient and stubborn, constantly trying to climb the ladder of complexity, but evolution requires stability on geological timescales to produce something as fragile as intelligence. If a planet is scrubbed clean by hard radiation every time its inhabitants figure out photosynthesis, the clock resets to zero, and the process must begin again from the primordial soup. The silence of the universe is not an indicator of emptiness. It is the quiet of a battlefield after the artillery has finished leveling the trenches, leaving only the mud and the bacteria to start over. This theory implies that humanity's existence is not due to any divine favor or biological superiority, but is merely a result of a phase transition in the galactic climate. We are living in a post-burst epoch, a relatively calm window in the history of the Milky Way, where the expansion of the universe has pushed galaxies apart and the rate of star formation has slowed down. The cosmic rate of fire has dropped just enough to allow a single planet in a quiet backwater spiral arm to go 4 billion years without taking a direct hit to the face. We are the beneficiaries of cosmic exhaustion, rising from the dirt only because the universe has partially run out of ammunition. This suggests that we may be the only intelligence in our galaxy, not because we are special, but because we're the first to wake up in the morning after a chaotic, violent night that killed everyone else in the house. We are the orphans of a dead galaxy, wandering through ruins that we mistake for a playground. The implications of this filter transform the night sky from a canvas of potential friends into a graveyard of almosts. When you stare into the deep field, past the local stars, you're likely looking at the wreckage of millions of worlds that were on the verge of greatness before the sky turned white. There were likely civilizations that mastered mathematics, poetry, and perhaps even the early stages of radio, only to be erased by a beam of light generated 5,000 years prior. They never saw it coming. They never had a chance to adapt, and their entire history was evaporated in seconds, leaving no ruins and no signals, just a scorched rock drifting in the dark. The Fermi paradox is solved not by the absence of life, but by the efficiency of death. The universe is silent because the sniper is extremely accurate, and for billions of years, it has been picking off anyone who dares to stand up. As we pivot from the galactic scale back to the intimacy of your own existence, you must internalize the sheer absurdity of the fact that you are currently conscious. Look at your hand, at the veins pulsing under the skin, and realize that this biological machine is the end result of an uninterrupted chain of survival stretching back for a billion years. Every single one of your ancestors, from the first replicating molecule to the fish that crawled onto land, managed to dodge the crosshairs of a hostile universe long enough to reproduce. But more importantly, the planet itself managed to avoid the cosmic executioner, drifting through a minefield for eons without triggering the tripwire. This is not destiny. This is a coin flip that has come up heads billions of times in a row, a statistical anomaly so improbable that it borders on the impossible. You are winning a lottery you did not know you entered, and the prize is simply the continued ability to inhale a mixture of nitrogen and oxygen for another few decades. However, the nature of probability is that streaks eventually end, and the gambler's fallacy offers no protection against the laws of physics. We treat our survival as a baseline, a guarantee that because we have been safe for this long, we will continue to be safe, but the universe operates on timescales that make human history look like a rounding error. The gun is still loaded. Stars like Eta Carinae and WR10 are currently spinning in the darkness, their cores churning, their poles drifting across the celestial sphere. We are essentially playing Russian roulette with a gun that has a barrel light years long, and we have no way of knowing if the trigger has already been pulled. The photon that ends us could be crossing the orbit of Jupiter right now, or it could be 1,000 years away, or it might not arrive for another million years. The terror lies in the lack of agency. We are not participants in this game. We are the targets, standing blindfolded against a wall, waiting for a sound we'll never hear. So, when you look up at the stars tonight, do not let yourself be seduced by the romantic lies of poets or the comforting ignorance of the past. Do not see a tapestry of destiny or a celestial symphony written for your amusement. See them for what they truly are, the muzzle flashes of a war that has been raging since the Big Bang, a war that we have miraculously walked through unscathed up to this point. The beauty of the night sky is the beauty of a nuclear explosion frozen in time, a display of power that is indifferent to your heartbeat and your hopes. We are drifting through a firing range, small and soft and incredibly lucky. And the only reason you are able to close your eyes and sleep tonight is that the universe has, for one more day, missed its shot. But do not mistake a miss for mercy. The barrel is still spinning.